Hello and welcome to This doesn't keep you too engaged. Sleep is the goal, after all. But if it does hold your attention, at least you'll have picked up something strange and beautiful before you slip away. So go ahead and settle in. Let your breathing ease up. Let your mind release its hold on the day. And let's begin. Because somewhere far below the weight of the waves, in a blackness older than bones, the story of the deep waits to be told. Let's start not with a fact, but with a feeling. Picture yourself on a beach at night. The tide has pulled back. Stars reflect in the wet sand, and the breeze is slow, unhurried. You look out toward the sea and sense something ancient looking back at you. That feeling, that blend of wonder and unease, it's not just poetic, it's biological. Humans have always felt something otherworldly about the ocean, especially the deep parts. There's no light down there, no markers, no clear sense of scale. And for a brain that evolved beneath the sun, this lack of reference is unsettling. The abyss doesn't just challenge our perception, it erases it. In the deep sea, there's no up or down, no sound that carries clearly, no horizon to hold onto. It's a place where the rules of physics bend gently toward strangeness. If you or I were to sink into the abyssal zone, even before the cold or pressure got us, our minds would start to unravel from the absence of input. No light, no sound, just the slow weight of water and the stretching of time. And yet, it pulls us in. There's something oddly familiar about it. Some part of us seems to recognize the deep as more than just a frightening void. Maybe that's because, in a way, it's home. Every human embryo, after all, floats in salt water. Our blood has the same saltiness as ancient oceans. And long before we walked or even crawled, we swam. That memory hangs on, faint but stubborn. It's why people stare at aquariums the way they do, why deep ocean documentaries feel almost meditative, why blue light feels soothing. Some researchers link this to what's called the biophilia hypothesis, the idea that humans have a built-in connection to natural environments. But maybe it goes even deeper than that, because the ocean isn't just nature. It's mystery in liquid form. It hides, it shelters, and it humbles. When you stand at the edge of the sea, you're not just looking at water. You're gazing into an evolutionary mirror, a reminder that the unknown isn't just out there, it's inside us too. And this strangeness, this pull creates a kind of tension in the mind, curiosity twisted with caution, a gentle internal tug of war. We want to look, but we don't want to fall in. We want to know, but we also want to stay safe on shore. So, what do we find when we cross that invisible line? When we dive not in dreams, but in steel and science, and begin to drop below the reach of light, we find pressure, we find darkness, and we find life. A kind of life that doesn't care what we expected. To descend into the deep sea is to leave human logic behind. Down here, fish carry lights on their heads, eyes the size of dinner plates, or no eyes at all. There are creatures who feed by creating vacuums with their faces, others who trap prey using their own tongues as bait. The rules of land life simply don't apply. Down here, nature isn't just surviving, it's improvising. And that improvisation sparks something in us. Wonder, yes, but also a strange kind of connection. Because like us, these creatures have adapted to a world they didn't choose. They're not monsters. They're solutions, floating equations worked out over millions of years that solve for pressure, darkness, scarcity, and silence. And maybe that's why the deep sea feels psychological. It reflects us in abstract, our fears, our adaptations, our longing for light in the dark. Just as we seek meaning in dreams and stories, deep sea creatures seek food, warmth, survival. And in their bizarre elegance, we catch a glimpse of ourselves. So next time you see a blobfish, a gulper eel, or a transparent jelly pulsing through darkness, don't laugh. Don't turn away. Look closer. You might just be seeing yourself in another shape, in another world, still floating. And now, having felt what the deep does to the mind, let's explore what humans have thought about it through time, how we've imagined the abyss before we ever touched it. Because before there was sonar, there were stories. Before we had cameras that could dive for hours or robots to map the ocean floor, we had imagination. And that imagination was understandably terrified. Nearly every ancient culture that lived near the sea also feared what lay beneath it. The deep was seen as the home of monsters, gods, spirits, and curses. The Babylonians told of Tiamat, a chaos dragon of salt water whose defeat shaped the world. The Greeks spoke of Charybdis, a sea creature who swallowed entire ships in whirlpools. The Norse had the Kraken, slumbering in the deep, ready to rise and crush hulls with its arms. Even today, those old ideas echo. In horror films, the ocean is never just wet. It's ancient, indifferent, patient, the perfect backdrop for fear. But it wasn't just mythology. Sailors, explorers, and early scientists tried to make sense of the abyss with what little they had. In the 19th century, many still believed the deep sea was lifeless, a barren void, too cold, too dark, too pressurized for anything to survive. It made sense in a way. After all, we couldn't see it. And what we couldn't see, we often assumed didn't exist. But then came a shift. In 1872, the HMS Challenger set sail on a groundbreaking expedition. It dragged nets, measured depths, and brought up creatures no one had ever seen before. Not monsters exactly, but strange life. Real life with odd shapes and glowing bodies. Creatures that had been hiding in the dark the whole time. This changed everything. The deep was not dead. It was alive, just quiet, just hidden. And slowly, we began to rewrite our stories. Science, of course, replaced myth. But even scientific language still carries traces of that older awe. We talk of the abyssal plane, the midnight zone. We use metaphors of ghosts and lanterns and alien forms because it still feels uncanny. Even now, with advanced submarines and sonar, we've explored only a fraction of the ocean floor. The deep sea remains the least understood ecosystem on the planet. More people have walked on the moon than have visited the Mariana Trench. And so, we continue to blend science with story. We watch real footage of deep-sea jellyfish undulating like translucent parachutes. And still, part of us whispers, "That's not from here." But it is. It's from Earth. It's just a part we haven't reached yet. And maybe that's the most important reminder of all. The abyss isn't elsewhere. It's part of our own planet, our own biology, our own story. So when we speak of what's hidden in the abyss, we're not just talking about unfamiliar creatures or vast geological trenches. We're talking about the frontier of our own understanding, the edge of the known, and the invitation to cross it. And with that, we gently drift into the science of what the deep sea actually is. Not what it feels like, not what we feared, but what it is. The deep sea through culture and myth. Almost every maritime culture has its own version. Scandinavia's Jörmungandr, the world's serpent who encircles the earth. Japan's Yumebazu, a shadowy giant who smashes ships. The Leviathan of Hebrew tradition, a coiled force of apocalypse. Even indigenous tribes of the Americas told stories of water panthers and underwater dragons. These weren't just stories to frighten children. They were ways to explain the unexplainable. A ship vanishes. A serpent took it. A storm sinks a fleet. The sea was angry. We lacked instruments, so we used metaphor. In medieval Europe, maps of the ocean included illustrations of fantastical beasts. Here be dragons, the cartographers warned, or sometimes, more literally, hic sunt dracons. And while many of these monsters were fabrications, they often had roots in real encounters. A beached whale mistaken for an island. A giant squid glimpsed for a moment in a foggy swell. A whale carcass, bloated and unfamiliar, described in letters that outlived the facts. The line between myth and observation was not clear, and perhaps, even now, it still isn't. In Chinese mythology, dragons were not fiery or evil, but wise and wet. They lived in palaces beneath the sea and controlled the rain. They were respected, even loved. Offerings were made not to appease them, but to connect with them. In contrast, the Bible portrayed the sea as chaotic and dangerous. In Genesis, darkness covered the face of the deep before creation. The book of Job describes Leviathan as untamable. The ocean here is a challenge to divine order. It must be subdued. This duality, the sea as origin and obstacle, runs through many traditions. In Hindu legend, the cosmic ocean churned by gods and demons yielded the nectar of immortality. But it also birthed poison. In Maori legend, the ocean is a bridge between worlds, but cross it carelessly, and you may not return. So much of early human understanding of the ocean acknowledging the shared cycle of life and death. These aren't superstitions, they're philosophies. They recognize that the ocean is not a thing, but a relationship. And the deeper we go, the more intimate that relationship becomes. Because to enter the abyss is not to conquer it, it's to be changed by it. As technology crept forward and the myths lost their edges, we didn't abandon the stories, we adapted them. Jules Verne imagined a submarine so advanced it could glide through the deepest trenches. H.P. Lovecraft conjured horrors from the seafloor that could fracture the mind. Even science fiction, for all its spaceships and stars, returns again and again to the ocean as metaphor. It is our alien world right here, wet, waiting, and very real. And maybe that's the true power of cultural interpretations. They don't explain the sea. They reveal us our hopes, our terrors, our desperate need to name what we cannot reach. And now, after the myths and metaphors, let us surface briefly and then plunge into the real. Because science, when done with wonder, is a story too. And the story of how we began to know the deep sea is every bit as strange as the legends that came before it. How we came to know the deep science began with ships, with ropes and lead weights, with sailors leaning over rails, lowering tools into darkness, and pulling them back up like fishing lines cast into myth. For a long time, this was all we had: plumb lines, sounding leads, and guesswork. One of the first major scientific efforts to truly investigate the deep was the HMS Challenger expedition. In the 1930s, descended 3,000 feet and offered the first real glimpse of deep sea life in its habitat. He described fish with lights like headlights, shrimp that glowed blue, an ocean that was not empty, but pulsing with slow, soft motion. And yet, Beebe had no photos. His reports were written like poetry, vivid, but unverifiable. Some scientists doubted his claims. Some still do. But his writing lit the spark. Then came Jacques Cousteau. With his invention of the aqua lung, underwater exploration entered a new era. Cousteau's films brought the ocean into homes around the world. While he didn't reach the abyssal zones himself, his work helped create a culture that valued ocean exploration. Submarines followed ROVs, deep diving vessels like Alvin, which in 1977 discovered hydrothermal vents along the Galapagos Rift. This was monumental, not just for the technology, but for what we found. These vents, spewing superheated water rich with minerals, were surrounded by ecosystems unlike any seen before. Giant tube worms, blind crabs, microbes that lived not on sunlight, but on chemicals. This was life flourishing without the sun. It overturned a central assumption in biology that all ecosystems ultimately rely on photosynthesis. These deep sea communities ran on chemosynthesis instead. Life, it turned out, didn't need the sky. This discovery shifted how we think about habitability. If life can exist here in the dark, under pressure, feeding on sulfur and metal, then why not under the ice of Europa? Why not on an exoplanet's ocean? The abyss became a model for alien worlds. And still, we'd only just begun to look. Today, less than 20% of the ocean floor has been mapped in detail. Not because we lack interest, but because the ocean is vast and the tools are expensive. Every expedition is a feat of coordination, funding, and luck. We send down autonomous robots. We listen with sonar. We sift through thermal readings and chemical traces, and piece by piece, the picture sharpens. But mystery remains. For every discovery, a dozen new questions rise. What is that sound heard 3,000 meters below? What is this gelatinous shape drifting in the current, uncatalogued, unnamed? Why do some creatures congregate at depth for no known reason, forming patterns that seem almost intentional? We're not just mapping terrain. We're mapping behavior, interaction, ecology. And we're doing it with a strange combination of tools: satellites orbiting in space, lasers bouncing off waves, and nets dragged behind ships much like those used centuries ago. The old and the new, the mythical and the measurable. We name zones: mesopelagic, bathypelagic, abyssopelagic, hadal. Each name more theatrical than the last, but they help. They create mental maps. They let us imagine pressure not just as force, but as geography. They remind us that the ocean is not just one place. It is layers of mystery stacked like a dream. And perhaps that's where science meets story again, in the realization that knowledge does not eliminate wonder, it deepens it. To understand that the gulper eel exists, that it can unhinge its jaw and swallow prey larger than itself, is not to kill the magic, it's to refine it. To name the glow of a lanternfish not as sea magic, but as bioluminescence, a chemical process of luciferin and luciferase, is not to dull the shine. It's to know it more intimately. And still we wonder, what else is down there? What haven't we seen? What languages are these animals speaking with flashes and pulses and migratory dances? We're no longer mapping myths, but we're not done telling stories. Only now the stories are written in data, in sonar shadows, in video clips of strange beings floating silently in the black. This too is a kind of myth-making. Only this time, we get to watch it happen in real time. The structure of the deep sea. Let's begin with something simple. What exactly is the deep sea? It's not just deep water. It's not simply where your feet can't touch the bottom or where the sun can't reach. It's a specific, measurable region of the ocean defined not by imagination, but by light, pressure, and depth. giant amphipods that look like armored shrimp, and jellyfish that bloom like galaxies. Most have adaptations for a life of drift and wait. They are not runners. They are floaters, lurkers, minimalists. Food is scarce. Energy must be conserved. Which brings us to the next essential concept: energy and food webs. Where does energy come from in the deep sea? If there is no sunlight, what feeds these creatures? There are three major sources. First, marine snow, a constant fall of organic matter from the upper layers of the ocean. Dead plankton, fecal pellets, bits of carcass. It drifts down like slow, soft snowfall, feeding bottom dwellers. Second, carcasses. Occasionally, a large animal, a whale, a shark, a sea turtle dies and sinks. This is a banquet. A single whale fall can feed an entire ecosystem for decades. First come the scavengers, then the hagfish, then bacteria and bone-eating worms. And third, hydrothermal vents and cold seeps. Here, life thrives not on light, but on chemicals. Chemosynthesis. Bacteria convert hydrogen sulfide or methane into usable energy. These bacteria form the base of a food web supporting clams, crabs, tube worms. And these food webs, they're ancient, possibly more ancient than photosynthesis-based systems. In the deep sea, life is not a race. It is a negotiation. Every adaptation is a whisper to the dark. Let me stay. And somehow, life persists in forms that shimmer, in forms that wait, in forms that no one has yet seen. And now, having set the structure, the light, the energy, and the pressure, we're ready to descend further. Because the deep sea isn't just a place, it's a world with its own physics, its own logic, its own rules of survival. In the next section, we'll meet the residents of the deep more intimately. Not just what they are, but how they live and how they challenge what we thought life could be. Meeting the residents, let's meet the residents. Start with the anglerfish, perhaps the most iconic face of the deep. A wide mouth, needle teeth, and a glowing lure dangling from its forehead like a lamp on a nightstand. But the most curious thing about it isn't the lure. It's the male. Male anglerfish are tiny. Some are 1/10 the size of females. And when they find a mate, they attach themselves permanently to her body. They bite her side, fuse their tissues, and eventually lose their eyes, fins, and even organs. They become part of her, a parasitic sperm donor, living in fusion. Not exactly a romantic comedy, but a brilliant evolutionary tactic for a world where encounters are rare. Or consider the gulper eel. Its mouth is so large it can consume prey much larger than itself. It doesn't chase. It simply opens wide and waits. The jaw unhinges, the skin stretches, and in goes whatever happens to be passing by. The vampire squid, despite its name, drinks no blood. Many deep-sea animals perform a vertical migration each night. From hundreds of meters below, they rise toward the surface under cover of darkness to feed, then return to the depths before sunrise. It's called diel vertical migration, and it's the largest movement of biomass on Earth. And it happens in silence every night while we sleep. The scale of deep sea life is also vast, from the giant squid, once thought mythical, now confirmed, to microscopic extremophiles living in the pores of rocks. Some creatures are long-lived, others barely have time to grow, and yet nearly all of them remain hidden. Why? Because light is limited. Human access is limited. Even with the best submersibles, we can only stay so long. We can only cover so much ground. And the creatures there, they often avoid us. Sound startles them. Light blinds them. Machines don't blend in. We are, in many ways, clumsy visitors. Even when we do see them, much is lost in translation. A jelly filmed by an ROV may pulse differently under stress. A fish may flee instead of hunt. These snapshots are just that, fragments, but they add up, and each new encounter stretches our definition of what life is. Take the Hadal snailfish, found in the Mariana Trench, deeper than any other known fish. It has no swim bladder. Its bones are soft, its flesh almost gelatin. It lives in an environment with more pressure than the surface of Venus. And yet it eats, it grows, it reproduces. Or the Ostax worms, also called bone-eating worms. They have no mouths, no stomachs. The females anchor themselves to bones such as whale falls and digest them using symbiotic bacteria. Males, they live inside the females, hundreds at a time. Their sole function, reproduction. We are far from the savannah now. Even viruses are different here. Some scientists believe the deep ocean harbors unique viral ecosystems, infecting bacteria and archaea in cycles we don't yet understand. These micro-interactions could shape nutrient flows, evolution, even climate. Every level of life, from the molecular to the monstrous, behaves differently in the deep. And perhaps the most astonishing thing, these creatures are not fragile. They are ancient, resilient. Many species have remained unchanged for millions of years. Some even survived mass extinctions that wiped out most surface life. Down here, change is slow, but survival unyielding. That is the lesson of the deep, that life does not need light to thrive. It needs time, space, and silence. In the next part, we'll explore the anomalies and edges of this world. Creatures that bend biology, vents that breathe minerals, and ecosystems that challenge our idea of what a biosphere even is. Because the deeper we go, the stranger life becomes. The truly alien, vents, seeps, and extremes. Let's step past the familiar strange and enter the truly alien. Because the deep sea isn't just home to weird creatures. It contains entire systems of life that defy what we thought was possible. Start with hydrothermal vents. Imagine a crack in the seafloor, thousands of meters down. From it, scalding water erupts, not boiling, but heated to hundreds of degrees Celsius by magma beneath the crust. The pressure keeps it from vaporizing. This water is dark, acidic, and full of dissolved minerals, hydrogen sulfide, iron, methane. And yet, around these vents, life blooms. giant tube worms with blood-red plumes, vent crabs, white and blind, Rifsha pachyptilla, which can grow taller than a man. These organisms don't eat in the way we understand. They rely on chemosynthetic bacteria that live inside them or coat nearby rocks. These bacteria take the toxic chemicals and turn them into energy. They are the base of the food web, lightless photosynthesizers, a different origin story for life. Discovered only in 1977, these ecosystems shocked the scientific world. They suggested that life didn't need the sun, that perhaps, even on Earth, biology had more than one blueprint. And then came cold seeps. These are areas where hydrocarbons methane, ethane, oil seep from cracks in the ocean floor. No heat, but still life. Clams with chemosynthetic bacteria in their gills. Mussels with Could there be vents there too? Even exoplanets, planets orbiting distant stars, may have oceans beneath ice shells or within atmospheric layers. Our definition of Earth, is shifting. Maybe it means watery. Maybe it means deep. Studying the abyss isn't just marine biology. It's astrobiology. It's learning how life might look when built from different rules. And perhaps most humbling, we still haven't found the bottom of it. New trenches, new species, new chemistry. Every dive is a chapter in a book we didn't know we were writing. And all of it, the glowing fish, the worm forests, the methane lakes, exists not in a fantasy world, but in the same oceans we swim in, the same waters we splash in at the shore. The abyss is not elsewhere. It's here, just hidden. So we continue to explore, not just with machines, but with questions. How does light shape behavior when it's only ever artificial? How do organisms mate when they may never meet? What does community mean in a world of drift? And when we look outward to alien seas, it will be these creatures, the worms, the jellies, the invisible shrimp that guide our search. Because they are the proof that life is not fragile. It is adaptive. And most of all, it is strange. Stranger than fiction. Stranger than fear. Stranger than we dared believe. And yet, utterly real. Tools of discovery. How we touch the abyss to understand how we came to know the deep sea is to tell a story of glimpses, of slow reveals, of tools invented not just to measure, but to believe. Because for most of human history, the deep ocean wasn't just inaccessible, it was unimaginable. Let's begin with sounding lines. Simple tools. Weighted ropes lowered from ships to estimate depth, crude, but effective. They told us the ocean had contours, valleys, slopes, that it wasn't just flat and endless beneath the surface. One of the earliest documented deep-sea soundings was in 1521, when Magellan's crew dropped a line in the Pacific and found no bottom at 730 fathoms. The line just kept going. The ocean swallowed it. Later, in the 19th century, lines grew longer, techniques improved. The British ship HMS Challenger in the 1870s conducted over 500 soundings. It reached depths of over 8,000 meters in the Mariana Trench, a discovery that stunned the world. But even then, we were still measuring absence. A rope tells you something is down there, but not what. To see required invention. Enter the bathysphere. In 1930, naturalist William Beebe and engineer Otis Barton built a steel sphere with tiny windows and a breathing system. Suspended by cable, they descended off the coast of Bermuda. No camera, no lights beyond their own, just eyes pressed to a portal, staring into black. They reached 3,000 feet, and what they saw changed everything. Fish with lights, jellyfish with internal flames, shrimp that glowed like coals. Beebe described a fish with the face of a pig and the body of a balloon, a luminous eye the size of a coin. Skeptics doubted him. No photos, no proof. But Beebe's poetic logs hinted at a truth science wasn't yet ready for. The deep was not barren. It was filled with light. In the decades that followed, technology caught up. Cameras built into pressure housings, lights that could survive the crush, remote-operated vehicles. And then came Alvin, commissioned by the U.S. Navy in 1964. Alvin was a small manned submersible capable of reaching deep sea floors. It was aboard Alvin that scientists discovered hydrothermal vents in 1977 and the ecosystems that surrounded them. Suddenly, the deep wasn't just deep, it was vital. Alvin also helped recover a lost hydrogen bomb, explored the Titanic, and became a symbol of how far human curiosity could reach. But it wasn't just government projects. In 1960, Swiss scientist Jacques Piccard and U.S. Navy Lieutenant Don Walsh boarded the Trieste, a bathyscaphe with a thick glass viewing window and a body built like a floating tank. They descended to the bottom of the Mariana Trench, nearly 11,000 meters down. No one had ever been there, and for over 50 years, no one went again. They reported seeing a flatfish, though later analysis suggested it was likely a sea cucumber or another benthic organism. Still, they proved it was possible that humans could touch the planet's deepest point. Since then, others have followed: robotic dives, autonomous vehicles, even filmmaker James Cameron in 2012, who soloed the trench in a custom-built sub called Deep Sea Challenger. These milestones mark progress not in distance, but in presence, each one a candle lit in the dark. And yet, for all this machinery, we still struggle with the same basic question: what's down there? Because the ocean, unlike space, is resistant to clarity. Water obscures, pressure crushes, darkness absorbs. Even today, mapping the ocean floor is like blindfolded cartography. We use sonar, bouncing sound waves off the bottom, translating echoes into shape. It works slowly. The most detailed maps of the seafloor come not from direct observation, but from satellites measuring tiny changes in sea surface height. These changes, caused by gravity and underwater topography, hint at mountains, trenches, and ridges. It's like reading Braille from orbit. And still, only about 20% of the ocean floor has been mapped with high resolution. There are mountain ranges bigger than the Andes we haven't named. Trenches deeper than Everest is tall that remain unexplored. Canyons that dwarf the Grand Canyon, sitting silent in the black. We've sent probes to Mars, The abyss is not a place of emptiness. It is a place of patience, of silence that holds secrets, of life that learned to thrive without light, without warmth, without anything we once thought necessary. It reminds us that the world is larger than our senses. That mystery is not something to fear, but something. It shows us that we are not the center, not the measure, not the only form intelligence or survival can take. It teaches us that life is flexible, inventive, stubborn, that it will find a way, even in the coldest, darkest, most impossible corners of the planet. And maybe, just maybe, that's comforting. Because if life can persist there, in the crushing silence of the Hadal Zone, then perhaps it can persist anywhere. Perhaps we too can adapt, can endure, can glow softly in our own darkness. So rest now. Let the weight of the ocean hold you, not to drown, but to cradle. Let the thought of those strange, glowing creatures drift through your mind like marine snow.